Chalo, let us start off with logarithmic inequalities. Very, very important, and expect around the same thing. Either you will get question from logarithmic equalities, equations, or from inequations. I told you either from equations or inequations. Okay. Rare case we have seen both the questions, like from questions from both the topics are asked actually. Okay, that is different. But whenever if they are giving question from inequalities or inequations, automatically those things equation concept is also involved over here. Okay, so similarly for to attempt the questions of these type, make sure the basics of logarithm, that is the properties and all, are very clear. Graphs, property, the functional properties and all, domain range is very clear. Otherwise you will have difficulties over here. Okay, I hope you do remember this thing. Chalo, let's move on to the first thing. What you need to learn is the increasing and decreasing function. Okay, some concept you have to learn, not the entire thing of the calculus meaning and all, like what you study and all in calculus. You have the in detail study of increasing and decreasing function is done under calculus. When we learn calculus, we are going to see the calculus meaning over there also. But let's since we have the application of these things over here in this particular chapter, so that's why it's necessary for you to learn some basics of increasing and decreasing function. What is an increasing function? Consider this particular graph, suppose. Okay, consider this particular graph. You may see from here. Let me use a different. This is too light color. I have considered 2 points over here, x1 and x2. Basically, in simple manner, in simple language, increasing function means for larger input values, you will get larger output values. As you increase the input, output will also get increased. Okay. So what is the graphical representation of this thing? This I have considered is the representation of an increasing function. If you consider this is increasing function. Okay. So what I have done is I have considered 2 points, x1 and x2. Okay. Here what you can see that x1 is less than x2. x1 is less than x2. Okay. You may consider some points also over here, like let's say 2 and 4 suppose. But in general, we have this thing. If we consider this is x1, then this much height is f of x1. Basically, this much height means this particular function value, you will have the function value over here. That's the function value, f of x1. And corresponding to this particular point x2, you will get the function value over here, that is f of x2. That is f of x2. You will get f of x2 over here. Okay. So what is the inequality? What you're getting from here? The structure basically, as x1 is less than x2. Let me write somewhere over here. Is that eraser? As x1 is less than x2. Observation is as x1 is less than x2. You can see that f of x1 lies below f of x2, which means f of x1 is less than f of x2. And this is what is the definition of increasing function in general. I'm going to show you with the help of an example also, but this is the definition I'm showing you. This is in general, we have this as the definition of increasing function. As x1 is less than x2, f of x1 is less than f of x2. Okay, so that's a in general definition we have. If x1 is less than x2, then f of x1 is less than f of x2. Okay. Second is decreasing function. Now, what is decreasing function? For larger inputs, you will get lower outputs. As you increase the input, you will see that the outputs will keep on getting decreasing. So accordingly, we have the structure of the graph of this function, that this is a decreasing function, the graph of decreasing function. F is decreasing. Okay. This is increasing. I may write down over here that the value that this is increasing graph, and this is decreasing graph. This is decreasing graph. So as you keep on getting the inputs, these are all the inputs. I told you inputs means the domain values, basically input and the corresponding output. So as you increase the inputs, you will see that output keeps on getting decreasing. Output keeps on getting decreasing. Okay. So suppose over here we have x1 and x2. I have considered 2 points where x1 is less than x2. X1 is less than x2. So let me write here, otherwise you won't be able to see the definition. If x1 is less than x2, okay, so from here this much height is actually f of x1, this much height is actually f of x1, which means this particular is a function value, basically f of x1, and this much height will be f of x2. This much height will be f of x2. This is the function value of x2 over here. So if x1 is less than x2, can you see one thing from here, that f of x1 lies above this particular function value of f of x2. Basically f of x2 is less than f of x1. So in this case, orientation of this inequality will change. That is, f of x1 will become more than f of x2. Orientation of this inequality changes. F of x1 is greater than f of x2. Clear? F of x1 is greater than f of x2. So this is what is the definition for decreasing function. So in case of decreasing function, if x1 is less than x2, then f of x1 is greater than f of x2. This is the basis of our today's class. The basic, actually, the base on which your entire class is standing is this concept. In case of increasing graph, orientation of inequality won't change. But in case of decreasing graph, orientation of inequality will change. Now let's understand the same concept with the help of an example. If I don't give you the examples, this won't be clear. So let us understand with the help of an example itself. Okay. Chalo, let's take the graph of log function only. Two types of log function. I hope by this time you know the domain of log function, range of log function, and the structures of the graph of log function. Okay, structures of the graph of log function. What are the structures? Basically, structure, I mean to say there are two types of graphs. I hope you all know this thing. There are total two types of graph of log function. One, what happens when the base lies between 0 and 1, and what happens if the base is more than 1. I hope you also know that what are the restrictions for the base of the function, base of the log function. Log x base a, whenever we say this thing, base cannot be 1, base cannot be negative. I hope you do remember these concepts. Actually, we have discussed earlier. We have discussed the same thing in functions also. We have discussed the same thing in log also. Base, what are the existence of the log function? Accordingly, we have two graphs. First graph, if you consider, in this graph, you can see that this was the graph when this was the graph of log. Let's say I have considered over here the graph of y is equal to log x base 2. Here, base is greater than 1. Base is greater than 1. When base is greater than 1, we have the graph in this manner. I hope you remember. We have studied on the functions. This is y is equals to log x base 2. Base is greater than 1. Obviously, this point is how much? This point is 1, 0. Okay. Base is greater than 1. So as you can see, as you increase the values, increase the inputs, for larger inputs, you will have larger outputs. Okay. For larger inputs, you will have larger outputs. You take any input, the outputs will be larger. You will get very bigger values of the outputs. Okay. So this is an increasing graph. By the structure of the graph, you all can see from here, this is an increasing graph. Okay. This is an increasing graph from here. Now, actually, this is increasing in this manner. Actually, this is also an increasing graph. You all can see this is also an increasing graph likewise. This is also an increasing graph. This is also an increasing graph. Sorry, not this one. This is also an increasing graph. Okay. Depends upon the concavity. This is concave upward. This is concave up and this is concave down. Okay. Concave up and concave down. So this is actually the facing concave downwards actually. Okay. So this is the inner deep meaning of the graphs we'll do under calculus concavity. Only the basic idea you just need to know. In case of the base, when the base is greater than 1, then you have an increasing graph of this function. Increasing graph of this function. So this is the graph of y is equals to log x base 2. So similarly, when base is lying in between 0 and 1, let's say you consider the graph of y is equals to log x base half. When base is half, what happens? You will have a decreasing graph, as you can see from here. You consider any points over here, you consider any values over here. Let's say in the first graph, you consider x1 and x2 is somewhere over here. So accordingly, x1, f of x1 will be somewhere over here. This is f of x1. And corresponding to x2, you will get f of x2 will be somewhere over here. Obviously, in this case, you can see that when x1 is less than x2, you can see that f of x1 is also less than f of x2. But for decreasing graphs, the criteria is different. You can see that this is having a decreasing graph over here. This is the graph of y is equals to log x base half. Speciality is over here. The base lies between 0 and 1. Base lies between 0 and 1. So when base lies between 0 and 1, we have a decreasing graph of this type. Now you take any input values and verify. You take any input values. Let's say from here, you take x1. Let's say x1. You are taking x1 here and x2 over here itself. So x1, corresponding to x1, we have f of x1 here. And corresponding to x2, we have f of x2 here. So obviously, in this case, you can see that when x1 is less than x2, you can see that f of x2 or f of x1 is more than f of x2. Okay, because f of x1 lies above this particular point of f of x2. This is f of x2 point and this is f of x1 point. Whenever we are seeing the graph, we see in this manner, right? We see in this manner and we see in this manner. Okay, ऊपर से नीचे से ऊपर, not ऊपर से नीचे, नीचे से ऊपर we see. So f of x1 will be greater than f of x2 in this case. So orientation of this inequality will change in case of decreasing function. This was only my target to show you. Orientation of inequality will simply change. If you want to see with the help of more examples, you can simply verify by taking some finite values of x as well. Let's say you want to take this function. Suppose y is equals to log x base 2 we are having, right? If we have 2 points, let's say 2 is less than 4. Obviously, 2 is less than 4. So if 2 is less than 4, then is log 2 base 2 is less than log 4 base 2? Definitely yes. Log 2 base 2 is less than log 4 base 2. Definitely yes. What is log 2 base 2? 1. What is log 2 base 4 base 2? What is this? 2. 1 is less than 2. Obviously this is true. Okay. This is the in general we have this thing. X1 is less than x2. F of x1 is less than f of x2. Next, what we have? Next, come down to this example. Suppose we have log x base half. Similarly, suppose if I consider 2 is less than 4. So if 2 is less than 4, is log x log 2 base half less than log 4 base half? Obviously not. This will be greater than log 4 base half. Isn't it? Because log 2 base half is how much? Half to the power minus 1 is 2. So this is minus 1. And log of 4 base half is how much? Half to the power how much will give you 4? Minus 2. Isn't it? Clear with this thing? What I'm trying to say? Is this concept clear? Of increasing and decreasing function? Bolo. The two graphs are clear to all. Okay. So next, I want to show you. You have one more graph. I hope you remember this thing. The graph of fx is 2 raised to the power x, let's say. That is also an increasing function. If you remember the graph, actually, fx is 2 raised to the power x. 2 raised to the power x. What is the graph of that function? I hope you remember that graph, actually. What is the graph? In this manner. That is also this is an exponential function. So the graph is in this manner. I hope you remember. This is the graph, actually, for 2 raised to the power x. Okay. And there was one more function. Suppose if fx is half raised to the power x. In case of half raised to the power x, then the graph would have been a decreasing function. We have all done this under functions. We have done this under functions. Okay. So here you can see that you take anything over here, x1, any point over here, let's say x2. So corresponding to here, this is actually f of x1 and this is actually f of x2. So you can see that when x1 is less than x2, f of x1 is less than f of x2. Orientation will not change. F of x1 means 2 to the power x1. 2 to the power x1 will be less than 2 to the power x2. Okay. Again, you can verify this using the help of an examples also. Okay. You may take this thing. Let's say 2 is less than 4. 2 is less than 4. Is f of 2 less than f of 4? F of 2 is less than f of 4. Definitely yes. 2 to the power 2 is less than 2 to the power 4, isn't it? 2 square is what? 4. 2 to the power 4 is 16. 4 is less than 16, which is obvious. And same thing goes for fx is half raised to the power x. Over here we have, as you can see, this is x1 and this is x2. So corresponding to x1, this is f of x1 and this is f of x2. So here you can see that when x1 is less than x2, f of x2, f of x1 is more than f of x2 because f of x1 lies above f of x2. So f of x1 is more than f of x2, which means half to the power x1 is greater than half to the power x2. Okay. You may verify this thing. Let's say 2 is less than 3. 2 is less than 3. So is half square less than half to the power 3? Is half square less than half cube or more than half cube? Obviously, more than half cube. Half square is bigger. Half square is means what? 1 by 4. And half cube means 1 by 8. 1 by 4 means 0.25 and 1 by 8 means 0.125. Isn't it? So this is with respect to one more function I have shown you. This is also one example of the two different types of exponential functions. With the help of exponential functions, I have shown you what is the increasing function and decreasing function. So these are the two types actually. Okay. You just need to know these things actually in order to proceed further. We need these concepts actually. Okay. Likewise, previously what we have seen over here in case of log x base 2 and log x base half. So when we have the base is more than 1, we are having increasing function. So when base is lying in between 0 and 1, then we have decreasing function. So this is a generalized version we can consider. When base is in general, when base is more than 1, we have increasing function, and when base is in between 0 to 1, we have decreasing function. When base is more than 1, orientation of inequality won't change, but when base is lying in between 0 and 1, orientation of inequality might change. So this is the thing what you need to be very careful of. Okay, this is the thing what you need to be very careful of. If over here, if x1 is less than x2, then log x1 base 2 is less than log x2 base 2. But in case if x1 is less than x2, over here for the next one we have f of x1, that is actually log x1 base half is greater than log x2 base half. Over these two things only, your entire chapter is actually have built it. The inequality section have built it. The others are actually the application of the concept is actually based on this only. When base is more than 1, orientation does not change. This inequality remains the same. X1 less than x2, f of x1 less than f of x2. When base is lying in between 0 to 1, orientation of this inequality changes. Base, because of this base is lying in between 0 to 1, it's a proper fraction, so orientation changes. X1 less than x2 means f of x1 is more than f of x2. Simple, remember in this manner. Orientation changes for increasing function, does not changes for decreasing function. When base is more than 1, orientation changes. When base is lying in between 0 to 1, orientation does not changes. Conclusion. Let's see the conclusion. Okay, so for a greater than 1, so that's what we have seen so far. Acha, ulta is also possible. Ulta, we haven't seen the vice versa. Vice versa we haven't seen. Vice versa is also possible. If vice versa means if log x1 is base 2 is less than log x2 base 2, then x1 is less than x2. This is the vice versa. Ulta thing is also possible. Okay, you may simply verify this from your example only. Like this example. If log 2 base 2 is less than, obviously see, log 2 base 2 is less than log 4 base 2. True. This value is true. So x1, x2 is what? 2 and 4. Obviously 2 is less than 4. So ulta thing is also possible, which means vice versa. If f of x1 is less than f of x2, implies x1 is less than x2. So this is what is there in the conclusion. So see the conclusion, two conclusions are there. One is this thing, for a greater than 1, if log x base a is more than log y base a, then x is greater than y. Okay, x is greater than y. Clear? If log x base a is more than log y base a, then x is more than y. And if x is more than y, then log x base a ulta. X is more than y, then log x base a is more than log y base a. See, basically same thing. We have for a more than 1, we have increasing function, increasing graph. So obviously for increasing graph, you will have no change in the orientation. So you can see that orientations remains the same. So greater, we have greater. Here we have greater, so here we have greater. Orientation changes when base lies between 0 to 1. Okay. Clear? So for 0 to 1, write this down as the first inequality. This is the first inequality, the first part of this inequality. If a lies between 0 to 1, log x base a is more than log y base a, then x is less than y. Because here the graph is decreasing, so obviously orientation changes. And then ulta, if x is more than y, then log x base a is less than log y base a. Okay. Basically, this first property is equivalent to say that every time you can see that the first property over here, let's say the first one over here is equivalent to say that log base a, actually you're converting, you're cancelling. In case of inequality, you can cancel. But you have to also keep in mind with the orientation of this inequality. Log x base a, you are cancelling out log base a and getting x is more than y. You can cancel out this thing. Base is the same. Obviously, base needs to be the same to cancel out from both sides. You can do this thing and write this as x more than y, provided that it is an increasing graph. If it is decreasing, you can cancel out, but orientation also needs to be changed. This is what you need to figure out. Okay. Easy conclusion. So far, we have discussed everything. I have shown you the examples also. How do we proceed? Okay. Chalo, next thing. Next, what we have? Another inequality. Let's see. Now, the remaining type of inequalities are basically the application of this particular conclusion, this first part of inequality, what we have seen so far. It's just the application of this thing. Another inequality. Chalo. So, another inequality is just the application of this particular concepts only, nothing else. What we have? Converting log to exponential format. This is the what we know in case of equality. Basically, we know this thing, isn't it? In case of equality, we know this thing. So for a greater than 1, see, if log a is more than y, then x is greater than a to the power y. Now, what is the concept actually? We know this thing. This is obvious in case of equality. This is obvious in case of equality, isn't it? We have seen this thing in case of equality. For a greater than 1, if this happens, actually what happens is if log x base a is equal to y is given, then what is the meaning of this thing? A to the power y is equal to x, isn't it? This is log, so this is anti-log. In the anti-log format, we have this thing. So now in case of inequality, it is slightly different. What is the difference? We have to check the orientation of this inequality according to the base of this structure. Base, according to the base, orientation will change or not change. If a is greater than 1, log x base a is greater than y, which means x is greater than, if you convert this thing directly, you can convert this thing, means this is what? Basically, if you convert this, you will get x is greater than a to the power, this y will come in the power of a to the power y is equal to x. That's what we are having. And here orientation will not change, because for a greater than 1, you will have a increasing graph. You will have an increasing graph from here. For a greater than 1, you will have an increasing graph. So for a lies between 0 to 1, obviously we'll have a decreasing graph. Now, although this will become a to the power y, but orientation in this case will change. Log x base a is greater than y, then x is less than a to the power y. Okay, so these two inequalities. The second inequality, write these two. Okay, 2 part 1 and 2 part 2. There are two inequalities you must keep in your mind. So if log x base a is greater than y, simple thing is you don't have to remember so much. Base is more than 1, increasing graph, orientation does not change. Sorry. When base is lying between 0 to 1, orientation will change. That's what we are having, be it any kind of inequalities. And this though follows by definition. A to the log x base a is equal to y means a to the power y is equal to x. So in the case of equality, we have inequality. Now sign changes according to as base changes. That's what you need to remember. That's all. So many things you don't need to remember. Only I told you first concept is important. Increasing, decreasing. Accordingly, this orientation changes. Okay. Take this down. So log x base a is more than y, which means x is less than a to the power y. Take this down quickly. Basically, for instance, for example, suppose if someone's asked you what are the values of x for which log x base 2 is greater than 1. For instance, example I'm taking. You are asked to find out those values of x for which log x base 2 is more than 1. What you will do? Obviously, this means, first of all, identify what is the base. Base is 2, which is more than 1. So which means we have an increasing graph. Orientation will not change. So this is equivalent to say that x is more than 2 to the power 1, which is 2. Okay. Which means x is more than 2. Clear? X is more than 2. Let's take one more example. Suppose if this is not clear, suppose you are asked to find out, let's say, log x base half. X base half is more than 3. If suppose you're asked to find out the value of this thing, x base half is more than 3, what you will do? Obviously, in this case, observation. What is the observation? We have the base is half, lying in between 0 to 1. So what are the values of x which is satisfying this inequality? Obviously, the values of x in this case will be x is more than, sorry, less than, obviously less than, orientation will change, less than half cube. Half cube, that is 1 by 8, means x is less than 1 by 8. But if you write only x is less than 1 by 8, you will go wrong. What is the reason? What is the reason behind this thing? X is less than 1 by 8. But definitely x is always positive. X is always positive, which means what is the solution? Solution is actually x lying between 0 to 1 by 8. Isn't it? X means what? The values of x means the domain. What is the domain? I hope you remember the restrictions. What are the restrictions? Do you remember the restrictions? Let me write it somewhere here. What is the domain of log function? 0 to infinity. What is the range of log function? All real numbers, minus infinity to plus infinity. I hope you remember this concept. Domain is 0 to infinity. Range is minus infinity to plus infinity. So 0 to infinity means what? The values of x. Domain means the values of x, input values. Input values is 0 to infinity. Right? Input values is 0 to infinity. So what is the idea? Basically, in case of solving inequalities of this type, write down one more point as a short note. I'm dictating it. Write this down as a note. While solving inequalities, keep domain in mind. Keep domain in mind. If you write this x is less than 1 by 8, you will go wrong. X is more than 0 also. X is less than 1 by 8 means it is lying between minus infinity to 1 by 8. You mean to say that minus 1, minus 2, all this will be taken by the domain, which is not absolutely wrong. You know that the domain is lying in between 0 to infinity, which is not possible to take negative values. So obviously, the correct solution is actually 0 to 1 by 8. 0 to 1 by 8. Clear with the concept? Write this down somewhere as a note. Write this down somewhere as a note that while solving questions on inequality, keep domain in mind. I'll show you the examples also. We're going to go to the problem solving sessions also, the question solving sessions. Obviously, there I'll show you how do we deal with the questions, how to keep in domain. These are simple questions. Obviously, you won't get these type of questions in the exam. Okay. You do one more question. Tell me what are the values of x. Tell me what is the values of x for which this particular inequality is satisfied. Suppose, let's say log x base half is more than 2. Log x base half is more than 2. You tell me what are the values of x which is for which x is satisfied. This inequality is satisfied. What are the values of x for which this inequality is satisfied? Quickly, quickly. What are the values of x for which this inequality is satisfied? Very simple question. Quickly, give the answer. What are the values of x for which this inequality is satisfied? Number 3 question. Log x base half is more than 2. Correct. 1 by 4. 0 to 1 by 4. 0 to 1 by 4. I hope this concept is now clear. 0 to 1 by 4. Why it is 0 to 1 by 4? As you can see from here, log x base half is more than 2. Means, first of all, here we have the base is half. Base is half, which means it is a decreasing graph. So decreasing graph means orientation of inequality changes. So this is log x base half is more than 2 means, this means x is less than half to the power 2. X is less than half to the power 2. Right? X is less than half to the power 2. Means x is less than 1 by 4. X is less than 1 by 4. But keeping the domain in mind, what is domain? What is the domain of log function? What are the values of x? X can take the positive values, which means x belongs to 0 to 1 by 4. X belongs to 0 to 1 by 4. This is the conclusion. 0 to 1 by 4. So what you need to do is you have to keep domain in mind. Okay. Now, if suppose, now here you are getting simple question. Obviously, these type of questions won't be asked in the exam. Okay. What you will do in that case? What you need to do actually? Now see, when we have X over here, when we have X, okay. In case of X or any kind of function, let's say log of fx is given. Okay, log of fx is given. What you will do, as I said, according to the note, keep domain in mind. Keep domain in mind. Domain. So domain will actually differ. Actually, what we are doing over here is, can you understand what we are doing over here? X is more than 0 and we are getting x is less than 1 by 8. From there, from these two parts, actually we are concluding x lies between 0 to 1 by 8. Why we are doing this thing? Basically, what we are doing in this case is actually we are taking the intersection of these two inequalities. We are taking the intersection of these two inequalities. So while solving complicated questions, what you will do? After solving x is less than 1 by 8, then see domain, solve for the domain, and then take the intersection of those two. See whether the intervals what you are getting is satisfying the domain or not. Okay. So once you solve the questions, then you will understand. Once you solve the questions clearly, the typical questions basically, then you will understand the concept. Okay. So far what I have said, you must keep the domain in mind. Okay. You must keep the domain in mind. Okay. Chalo, next. Let's move to the second inequality, third inequality, another inequality. Again, same logic base, just the previous concepts only, nothing else. Previous concepts. So what we have here? Log x base a is more than 0. Log x base a is more than 0 means if either when this log x base is more than 0, when log x base a is positive, if either x and either the number and the base is more than 1 or the number and the base lies between 0 to 1. For these two situations, only log x base a is positive. You can take some values and verify also. Take any values and verify, you will get this result. For instance, means sign will not change. Sign will not change. Either x and a are more than 1 or x and a lies between 0 and 1. You can verify this thing. Let's say log half base half. Log half base half. How much is this thing? 1. Isn't it? Half base half is what? 1. Which is positive. Which is positive. So half base half I have taken, x and a lies between 0 and 1. Okay. Now suppose I am taking log of, let's say x and a is more than 1 suppose. So I am taking 2 over here and 2 over here. So 2 base 2, again what? 1, positive. Now if suppose if I am taking log of let's say log of 2 base half, suppose I am taking 2 base half. What is it? Minus 1. It is becoming negative. If either of the base or the component is opposite, basically one is lying between 0 to 1 and the other one is lying in between, is more than 1 basically. In that case, log of x base a will be negative in that case. Otherwise, it is not negative. If both of them is more than 1 or both of them is lying between 0 to 1 at a time, then it is positive. But if one is lying between 0 to 1 and the other one is lying between it's more than 1, so obviously the output will be negative in that case. So you may take this down also, which is just the direct application of the previous property, basically nothing else. This is the application of the previous property. You may take this down. Okay, so the previous two and these two. So total we have done 3 inequalities. Each inequality has 2 parts. Okay, so far we have done. Take this down and then we will proceed. Chalo, next. Solve this question. Try to solve this question first. Log x minus 1 base 2 is more than 4. Log x minus 1 base 2 is more than 4. Then what is the result actually? For what values of, basically solve means solve for x. Solve means solve for x. So x minus 1, first of all, log x minus 1, understand log x minus 1 base is what? 2. Base is 2. So it is a increasing function, increasing graph. So x minus 1 will be greater than 2 to the power 4. So which means x is greater than 17. In case of increasing graph, I can say you that you need not take care of the domain, because what happens if you see what is the domain of the function? Domain means this must be positive. X minus 1 must be greater than 0, which means x is greater than 1. Which means x is greater than 1. Okay, x is greater than 1. So x is greater than 17 and x is greater than 1. If you take the intersection, then clearly you can see that over here we have x is more than 17 and x is more than 1. Okay, x is more than 17 and x is more than 1. So if you take the intersection means common region. So what is the common region? More than 17 only. So this is the solution in any case. So this is the solution. X is more than 70. This is the solution of this inequality. Now you try to solve the next question. Solve this question. See, step by step we are doing, step by step. First step, observation. What is base? 3, more than 1, which means increasing graph, orientation won't change. So this means x minus 2 is less than or equal to 3 to the power 2. So which means x minus 2 is less than or equals to 9, which means x is less than or equals to 11. Okay, x is less than or equals to 11. And you can see from here, if you write x less than or equals to 11 is the solution of this inequality, you will go wrong. Why you will go wrong? Because x less than or equals to 11 means you are also saying that it also involves the negative quantities minus infinity to 11, obviously, which is wrong. So in that case, what you need to do? Observe domain of the function. I told you in case of inequalities, observe domain of the function. So x minus 2, what is the domain basically? Whatever is the function, log of fx must be positive. Log of fx, values of x must be positive. So in the place of x, we have x minus 2. So x minus 2 means x minus 2 must be greater than 0, x must be greater than 2. So if x is greater than 2 and x is less than or equals to 11, which means x belongs to open interval 2 to 11. Why it is so? Because we are taking the intersection of these two. If you take the intersection, I hope you remember, how do we take the intersection? This is 2 and this is 11. More than 2. More than 2 means over here, more than 2. 2 to infinity and less than 11. Less than 11 means over here. So what is the common region? This is the common region. This is the common region. Excluding 2, because here we have open interval at 2. So x belongs to 2 to 11. Okay. Chalo, next. Next question. Next question for you to solve. Solve x square minus 4x plus 3 base 3 is greater than 1. So first of all, what you need to do? Over here in this question, observation. What is the observation? Till now, whatever we have seen, one more thing, till now, whatever we have seen, this expression inside portion was either linear or with some constant. Constant means basically x or something. X variable only, x minus 3 or x minus 3 linear. So this is now x square minus 4x plus 3. So what changes will be there? Okay. Since from Friday we are going to start off with domain range concept also. So this will also help you there also. Log x square minus 4x plus 3 base 3 is more than 1. What does this says? What is the meaning of this thing? This means x square, first of all, observation, 3 is more than 1. 3 is more than 1. So this means x square minus 4x plus 3 is greater than 3 to the power 1. Step by step we are going. We are also going to check the domain also. So this means 3 and 3 cancels out over here. Basically we have x square minus 4x. X square minus 4x is greater than 0. How do we solve this thing? How do we solve this thing? Wavy curve. X minus 4, x into x minus 4 is greater than 0. How do we solve this thing? Number line 0 and 4. Okay. More than 4, in between 0 to 4 and less than 0. More than 4, suppose 5. This is positive. Then keep on changing the sign. Positive, negative, positive. So x belongs to which region we want? We need the region where it is positive. So x belongs to infinity, minus infinity to 0. This region, we need this region. Okay, this region and this region. So x belongs to minus infinity to 0, union 4 to infinity. Okay. But is this the right solution? Is this the correct solution? This depends upon the domain of the function. This depends upon the domain of the function. Now for domain, what you know? Log of anything is given. Log of fx base a. Any function is given of this type. Fx for the defined of function to be defined, fx must be greater than 0. Means this is your fx. So x square minus 4x plus 3 must be greater than 0. You are supposed to solve this and verify that whether these values of x lie in the domain or not. If this does not lies, we are going to take the intersection basically, nothing else. We are going to take the intersection. Nothing else. Simple intersection. Solve these two inequalities separately and take the intersection. In case of inequalities, take care of domain, I am telling you. So factorize this thing. How much it is? Minus 3x minus x. So this is x minus 3 and x minus 1. X minus 3 and x minus 1 must be greater than 0. This means x belongs to where to where? X belongs to simple. Once again, wavy curve method. What is it? 1 and 3. So more than 3, in between 1 to 3 and less than 1. So more than 3. This is positive, negative, positive. So we need the region where this is positive. So this is, we need this region and we need this region. So x belongs to minus infinity to minus 1. Sorry, minus infinity to 1. Union 3 to infinity. Here we have open interval, means we have strictly greater than 0. So we have taken open interval over here. Minus infinity to 1, union 3 to infinity. Clearly we can see from here, this interval contains in this interval domain. Domain is actually what is getting satisfied. The entire function gets satisfied basically, isn't it? If you take the intersection, you can clearly see from here itself. See, minus infinity to 1 and here we have minus infinity to 0. Obviously, minus infinity to 0 contains in minus infinity to 1. This is a subset now. We are going to take the intersection, common region basically. Similarly, 3 to infinity is there, 4 to infinity is there. Obviously, 3 to infinity contains under 4 to infinity. Basically, what I'm trying to say, if you take the intersection also, see on the number line concept also, if you take the intersection, minus infinity, and this is plus infinity. What are the points? 0, we have 0, 4, 1, 3. So plot the points. This is 0, 1, 3, and 4, suppose. Okay. 0, 4, 1, 3. Not at all points? Yes. And minus infinity. Towards the left hand side, we have minus infinity and plus infinity. So more than 4. basically what is given actually? Minus infinity to 0. Minus infinity to 0 means less than 0. Less than 0, minus infinity to 0. Okay. Then 4 to infinity means this side, 4 to infinity. Towards the right hand side, we have 4 to infinity. Then minus infinity to 1. Minus infinity to 1 means this region. Okay. Minus infinity to 1, left hand side. Then 3 to infinity. 3 to infinity means this side. So what is the common region? Can you find a common region? What is the common region? Isn't this the common region? This is the common region from the left hand side, and this is the common region from the right hand side. Means 0 to infinity minus infinity to 0. This is the common region, and 4 to infinity is the common region. You can directly see from here itself. You don't need to do such things over here. This is just for visualization. You can directly see from here. This particular interval is contained over here, isn't it? So clearly, what is the solution? This is the solution. So this is why it is important to check the domain. Every time domain, you have to see, you have to solve for domain, and then you have to take the intersection. Very, very important concepts you will see under domain range also. Done. Clear with this thing? Any questions here? Any questions with this problem? Shall we proceed? Next one. Chalo, next one. Now you all solve this thing by the same concept. Can you solve this thing? By the same concept, can you solve this thing? And tell me what is the solution? Basically, the intervals you need to solve. That's 0.3 in the base, log 0.3 x square minus component is x square minus x plus 1. This must be greater than 0. You tell me what is the solution for this particular values of x. Tell me, solve this and tell me what is the solution you're getting from here. All the types of questions I'm covering over here. You must have the idea of all the types of questions over here. Okay. You will solve. Then to satisfy your solution, you will refer to the domain of the function. For domain, what you will do? Whatever is the component, log of anything, log of x square minus x plus 1. Here we have log of fx, log of gx, whatever function it is, the function must be more than 0. Okay. That's what the same concept we're going to discuss on the Friday class also. In case of domain and range, we are going to enter into functions part 2. Correct. Very good. 0.3 is the base. Observation, 0.3 is the base, means decreasing graph, orientation changes, which means if you convert this to anti-log, this will become x square minus x plus 1. Orientation changes, greater than will become less than 0.3 whole to the power 0, which is 1. Right? Concept remains the same. Whatever we have solved since previously, this is actually less than, this will become less than 0.3 whole to the power 0. So that is 1. So x square minus x plus 1 is less than 1. So this 1 and 1 cancels out. Here we have x square minus x is less than 0. So x into x minus 1 is less than 0. Okay, x into x minus 1 is less than 0. How do we solve this? 0 and 1. More than 1, in between 0 to 1, and less than 0. So more than 1, this is positive, obviously, negative and positive. So x belongs to where to where? X belongs to open interval 0 to 1, because we need the portion where this is negative. So this is open interval 0 to 1. So is this the correct solution? To verify this thing, what we do? We find out the domain of the function. And we see that whether this and the domain, after taking the intersection, whatever it is, that is the solution. Okay, whether this satisfies the domain or not. Okay, according to the domain, we are going to proceed. X square minus x plus 1. What we have? Log of fx. I told you log of anything. Log of anything is there. Log of fx. For domain, what you do? Fx must be greater than 0. Fx must be greater than 0 means this is fx. X square minus x plus 1 is fx is greater than 0. X square minus x plus 1 is greater than 0. Can you see one thing? Observation. This is what? A quadratic expression having d less than 0, discriminant is less than 0. Do you remember the concept? D less than 0. A is equal to 1. Coefficient of A is 1. It means A is positive. A positive, D less than 0. What is D? B square minus 4AC. So B square is what? Minus 1 whole square minus 4 into A into C. Okay. So 1 minus 4. So minus 3 less than 0. So you cannot factorize this expression. Linear factors you cannot do in terms of real number. So but do you remember the concept? A greater than 0, D less than 0, we have discussed under basic mathematics. A greater than 0, D less than 0 means expression is always positive. Means this is always true. This is always true. This is always greater than 0, which is the property of log only. This is always true. This is already greater than 0. And this is contained in this particular thing. 0 to 1 is contained under 0 to infinity, obviously. So what is the solution? Intersection of those two. This is your solution only. Intersection of those two. X belongs to 0 to 1. Bas, khatam. Clear? Okay. Chalo, next. I think that's the last question. Fifth one. Try out. Solve log x minus 1 to the base 0.04 is greater than or equals to log 0.02 base x minus 1. So many things are given. Try to solve this thing. Now don't cancel out from both sides. Obviously, you can see that base are not the same. Okay. Although decreasing whatever it is, but don't cancel out. You have to simplify this first. Change the base. Change the base, make it equal and then try to solve. Okay. Balance the bases on both sides. Otherwise, cancellation is difficult, isn't it? Balance the base first. I hope you're understanding what I'm trying to say. Balance the base first and then try to solve. Okay. So let's solve this. We will take time to solve this. We don't have much time, so let's solve this quickly. Log 0.04 and here we have 0.2. If we balance the bases means you have to bring the base, same base on the left hand side, right hand side. So what you do? One thing can you observe? 0.04 is nothing but 0.2 whole square. 0.04 is nothing but 0.2 whole square. So this is log x minus 1 and this is 0.2 whole square is greater than or equals to log of x minus 1 base 0.2. Now see, power is with the base. Power is with the base. So this will come down as 1 by 2 by the properties of log. This will become 1 by 2 log x minus 1 base 0.2. Sixth property. I also remember the number of the property also. Sixth property. Log of x minus 1 base 0.2. Now we can multiply with 2 on both sides, 2 being a positive quantity. Log of x minus 1 base 0.2 greater than or equals to log of 2 times log x minus 1 base 0.2. Again, 2 times log x minus 1 base 0.2. We can take this 2 in the powers of this component. This will become log of x minus 1 base 0.2 greater than or equals to log of x minus 1 whole square base 0.2. Clear? Okay. Now you can cancel out the log from both sides, keeping in mind the base being 0.2, which is lying between 0 to 1. I'm doing it over here. Base lies between 0 and 1, which means orientation will change. If you remove the log, definitely you can remove the log, but this will become x minus 1 less than or equals to x minus 1 whole square. Is this concept clear? We are simply using the properties, nothing else. The first property, that if you remove log and the base is lying between 0 to 1, which means it's a decreasing function, then orientation needs to be changed. Okay. Orientation changes. Greater than or equals to becomes less than or equals to. Clear? Now we are just to solve this thing, solve this inequality. How do we solve this? Easy to solve. This is what? X minus 1 whole square. Let's simplify this thing. Minus x minus 1 greater than or equals to 0. Simple wavy curve method, inequality. So take out x minus 1 common. So here we have x minus 1 minus 1. Is greater than or equals to 0. So this is x minus 1 into x minus 2 greater than or equals to 0. So solve this now. How do we solve this? Wavy curve 1 and 2, more than 2, positive, negative, positive. So what is the solution? We need the region where this is greater than or equals to 0. So we need this region and we need this region, which means x belongs to where to where? X belongs to open interval minus infinity to 1. Okay. Union 1 close interval, because here we have greater than or equals to. And union 2 to infinity. 2 to infinity. Okay. 2 to infinity. Now observe left hand side. If you take x is equal to 1 close interval, what this will become? 1 minus 1 0 log 0 undefined. Right hand side, you take x is equals to 1 minus 1 0 log 0 undefined, which means x must be greater than 1. Observe the domains, x greater than 1 from here, x greater than 1 from here, x must be greater than 1. X minus 1 is greater than 0 means x is greater than 1, which means x1 cannot be included in the solution. So final solution, what is it? X belongs to, I'll write down over here, x belongs to, basically what we are going to do is simply take the intersection of these two. Intersection of this thing, intersection of these two. Let's take the intersection. Intersection is how much? X is greater than 1 from the domain x is greater than 1. So what are the points we have? We have 1 and we have 2. So more than 1 means this thing. More than 1 means this thing. Okay. And more than 2 means this thing. Okay. More than 2 means this thing. And minus infinity to 1 is this thing. So obviously we won't consider that. The common region is where? Common region is this. This is the common region. Okay. Obviously x is more than 1. So we won't consider the negative side. So obviously x is greater than or equals to 2 is the final solution. X is greater than or equals to 2 is the final solution. Is this clear? Question is clear? How we have solved? X is greater than or equals to 2. The concept remains the same. You solve this, take the intersection with the domain of whatever is given actually. After reducing, you're supposed to solve this with respect to the domain of the function. Okay, clear? Take this down. Okay. I think one more question is there, most probably. Yes, one more question is there. Solve. Again. Now see the difference over here. In the place of the function here, we have x mod of x minus 3. Log of base 0.2 and here we have mod of x minus 3 is greater than or equals to 0. How do we solve this thing? First of all, observation, again the same thing. Mod of, here we have the base is 0.2. Base 0.2 means it lies between 0 and 1. If this lies between 0 and 1, so obviously it is a decreasing graph, right? Which means orientation changes once you convert this thing. So this will become what? Mod of x minus 3 is greater than or equals to, sorry, less than or equals to, this will become less than. This will become less than or equals to 0.2 raised to the power 0. Why this will become less than or equals to? Because of this thing 0.2 whole to the, this is base is 0.2 lying between 0 and 1. Obviously in this case it is negative, sorry, decreasing graph actually. So orientation changes, greater than or equals to becomes less than or equals to. So this is how much? Mod of x minus 3 less than or equals to 1. Can you solve this inequality? Simple inequality. Okay. Also, one more thing, mod of x minus 3 is greater than 0 also. Keep this in mind also. We have to solve this inequality also. Let's do one thing. Let's solve this all together. Let's solve this all together. Can we combine this and solve? Mod x minus 3 is less than or equals to 1. Also, mod x minus 3 is greater than 0. So if you combine these two, ultimately we have to take the intersection only, right? It's the same concept only. Basically, if we combine this thing, we will get this inequality. Is this portion clear to you? If you combine these two, basically you will get the same type of inequality. Okay, this is what the domain basically. Domain, we are finding the domain, right? Ultimately, we have to solve this and take the intersection. So why don't we just solve this all together and just find the solution from there? Isn't it? Combination of these two we can solve. Now these type of inequalities we have solved previously in basic mathematics. I hope you remember modulus inequality. Now here we are not including 0. We are excluding 0. We are excluding 0. So mod of x minus 3 is less than or equals to 1. From this particular portion, what we'll get? X minus 3. X minus 3. I hope you remember. How do we solve this? X minus 3 lies between minus 1 and 1. Okay. What else? Mod of x minus 3. Also x minus 3. Sorry. X minus 3 is not equals to 0. We won't include 0. Isn't it? We won't include 0. I hope you remember this concept, right? When mod of x is less than equals to a, automatically it is assumed that this is greater than or equals to 0 also. But here we don't have greater than or equals to 0. Here we have strictly greater than 0. So we are not going to include 0 in this case. Okay. Okay. This and this has the same meaning. How do we solve this? We solve this by in this manner. X lies between minus a to a. Isn't it? X lies between minus a to a. But how do we solve when we don't have equality here? We simply exclude 0. Likewise, what we have done here. In case if you have doubt in this thing, you have to watch basic mathematics. That means you haven't done the basic mathematics lecture, attended the lecture. Minus x minus 3 lies between minus 1 to 1. What is this actually? So add 3 on all three sides. So here we get, we need the values of x, right? Add 3 on 3 sides. So here we add 3 minus 1, 2 and 3 plus 1, 4. X lies between 2 and 4 and x not equals to 3, which means x belongs to close interval 2 to 4 except 3. Except 3. Close interval 2 to 4 except 3. This is the solution of this inequality. Except 3. Because at 3 you can clearly see at 3 this will become 0, right? 3 minus 3, mod of 3 minus 3, this will become 0. Log 0 undefined. Okay. This type of inequality, if you are still confused, this inequality mod of x less than a, less than equals to a or less than a, whatever. If there is an equality sign here, this inequality is equivalent to this inequality. I have explained this. Whenever we have mod of x less than equals to a, it is assumed to be mod of x is also greater than or equals to 0. And from here you get the solution. X lies between, how do you get the solution? X lies between minus a to a. But in case if you have this thing, equality is not there at 0, how do we solve? Then we solve in the same manner. Mod of x is, this is equivalent to say mod of x is less than equals to a. Only from whatever is the solution, we exclude this portion, exclude 0. We exclude 0. Whatever is the solution, basically, if you solve this thing, you will get minus a to a. You'll solve this thing, you'll get minus a to a, and from there you're going to exclude 0. This is how we have solved. We have done this under basic mathematics while doing modulus inequalities. Clear with this? Okay. Okay. That's all. We have done 6 questions. The remaining questions we are going to continue in the DPP discussion session.